Hi, I am Merve. I have studied with Egecan in that project, and our advisors are Fatih Alagözan, Beytullah Yiğit. In that project, we have worked on slow rate flow table overflow. First of all, the STM structure contains three parts: the application part, control plane part, and the data plane part. Data plane part contains the hosts and switches, and the controller are the mind of the network. They just controllers build flow rules to the switches, and switches just uses the flow rules to forward packets from host to other one. And as we can see, flow tables should be used in a fast manner, so they just use TCAM memory, which one is really expensive, and the memory of the TCAMs are limited. And the other part is controllers have limited CPU and memory, and they generally has many applications, and also the routing algorithms. They should be protected well. And our problem is slow rate attacks. But what is slow rate attack? Slow rate attack aims to fill the flow tables with malicious attacks, so that the Bennings flows cannot go the place they want to go. And in that manner, slow rate attacks are sending the packets and building the flow rules in slower, so that they could not be understood by the firewalls and the other dummy algorithms. As we can see, it's a high rate attack, and the other one is slow rate attack. There are many solutions, and there are many solutions, such as using the idle timeouts, or just using statistical analysis of the some parameters of the system, or just if the capacity are high and then randomly dropping the flow rules. And the other option is ML models. But the side effects are high CPU usages of the algorithms, high bandwidth usages of the algorithms, since they monitors the switches all the time, and delays on the Benning traffic coming from the mitigations method. And our model proposes the decreasing the network usage of the ML models, and mainly it just uses it with controller async messages. It updates switches information, and the switches stores the switch statistics without sending network information. And if monitoring stores the information, and predicts uses ML algorithms to find the anomalies in the batches. Batches means the general information about the switch's health, and if there is a problem, it can be high rate or low rate. We just find which one is it, and after that we have to find the malicious flaws, so that we want to be unsure about the statistics of the switches, and we want them from the switches, and then we separate them black and white list. Black lists are malicious, and white lists are elephant floats, which have high volume of bytes during in the network, and they have expensive operations. We want to store them, and we ask our ML model if the flow is malicious or not. According to that information, we in the mitigator we ban the IP source we banned the IP source to handle the network. We have used our datasets and the other real life dataset, which one is IMC dataset. The IMC dataset. We also mimic the attacks with reading articles from the academia, and the other one is banning data. We have generated banning data as well. We have used many terminal command tools like iperf3, hping3, and ping. Our results are really good. As you can see, we have high results. As you can see in XGBoost, it's 1 and 1. We have decided that we have to increase our dataset volume to dataset volume to be unsure if there is any overfilling or not. Thank you for listening.